This is CS50 and the end of week 8. So just a couple of quick FYIs. As announced on Monday, this is now final project season, where you start thinking about what you would like to do for your own final project. As part of that process, there's a pre-proposal due in a couple of weeks. And this really is as simple as sending an email to your TF and just bouncing ideas off of him or her. Do look to the PDF that's posted on the course's homepage now as to the particulars. But this is really just an opportunity to start thinking about what you might want to do. Seminars, too. The schedule is in the process of being put together. And if you would like to register for any of the seminars linked on the course's homepage, by all means, feel free to do so. They will all be filmed. And then also a word on APIs, because this is an acronym you'll see in the PDF of the final project specification. And we'll come back to this over the next couple of weeks in the context of web programming. But an API is just an application programming interface. We mentioned this very early in the semester as the name given to code and data sets that other people, generally on the internet these days, make available for people like us to integrate with. Case in point, if you've used CS50's course shopping tool, Harvard Courses, well, and you've logged into that site most likely with Facebook. And that's thanks to the Facebook API for authentication. There's a similar API for the like button. There are APIs with which you can automatically send emails or text messages, with which you can access dining hall menus, shuttle schedules, and the like. So realize that that URL, even if the technicalities don't make a good amount of sense just yet, know that they soon will. So on problem set 5, we asked you to critique some piece of hardware or software or generally a user interface, whether on campus or beyond. You all had a lot of critiques, shall we say, a lot to say. We thought we'd excerpt just a couple of them. One of my favorites was this one. If only because 618 people would disagree. So that's the stack of papers there. But some of them were actually, almost all of them were quite thoughtful and actually quite detailed. And know already they have been escalated up to the powers that be so that hopefully we as a class can chip away at any of the concerns you've had with poor design. So one of the most polite ones we got to was this one, which I enjoyed. No one else really sort of like qualified their thoughts with such respect as this one here. But it was a very gentle one. Another favorite of mine critiqued the elevator in Mather House, which apparently, when you take it up from first floor to top floor, it just then stays there. And apparently no one really ever takes the elevator down. So the side effect of this behavior is that the elevator always stays on the 4th floor by default. So you always have to wait for it on the 1st floor. So a very apt commentary there. This one, too, was one of my favorite critiques. This student has trouble turning on the TV in the candidate common room. But in fairness, if you do read on, their critique is quite justified. I'll wave my hands at some of the particulars here, but it sounds like there's a whole lot of buttons and a whole lot of unnecessary complexity simply to watch a show that you would like. And one of the recurring themes as it related to CS50 actually related to the CS50 appliance. You know by default when you boot up the appliance, the window is actually deliberately rather small, the idea being that this way it works on anyone's laptop these days with high probability. But you can actually enlarge the screen. Just clicking the little button in the top right corner is not sufficient, though, because the appliance is running its own operating system. And technically, that operating system by default doesn't know it's inside of a virtual machine. Linux, Fedora Linux, just as soon assumes that it's running on a piece of bare metal, an actual computer. So for it to take advantage of your full screen and something called your graphics card or your video driver, you actually have to kind of train the appliance to know a little something about your Mac or your PC or your Linux box. And the trick for doing so is something called guest editions. So guest editions are software for free that come with VirtualBox that you can install inside of the appliance. And once you do and restart the appliance just once, then it will fill the screen just as I've been doing all semester here in lecture. And the documentation for doing so, if you would like to go that route, if you haven't already, is available at the CS50 manual at that address there. So realize there is that solution and plenty of others there as well. All right, so without further ado, and actually just to paint a picture of the depth of the comments, we went ahead and went through the 600+ critiques that were submitted, and then we excerpted for public display only those that related to Harvard so that we could forward them up to the powers that be and also allow you to sort of empathize with each other or see the sort of themes that arose. I actually first exported all this data as an Excel file, then started reading through it and sort of delighting in all of the critiques, and then very quickly got overwhelmed and bored with just like, my God, all of the copying and pasting I was trying to do into the course's website. So it turns out I'd taken CS50. So I wrote a little program and started searching for, programmatically, not with just Control F, but writing code that searched for a few themes. I realized that I could very quickly churn through the results by searching for my.harvard. Preterm planning tool was another good expression to search for. Another one was anything relating to dining services. Another was plan of study. Sectioning, and a whole bunch of others. And it was actually quite fun to see this, because every time I would add another if condition in the code saying, if this student mentioned my.harvard, put them at this point in the website, the numbers would go from like 600 down to like 500 comments, and then down to 400 comments. So it really is testament, frankly, with what you can do with just a little bit of PHP, which is the language we will introduce today. So for more on this, and quite the opportunity for procrastination, you can read through all of your classmates' critiques on things here at Harvard. So hopefully, collectively as a class, even that's getting long. Hopefully, as a class, we can do a little something about that. Indeed, for your final projects, if you see something on campus that sucks, fix it. Build it yourself, whether it's some CS50 tool or something else on campus. And we'll see what we can do about making real people use it. So my favorite thing in high school, frankly, was watching movies in class. This is not a full-fledged movie. It's actually just 10 or so minutes. But as promised, this will peel back the hood of the internet and show us in much more interesting detail how things underneath the hood work. But just a few pieces of jargon so that you know what to expect here. So we talked on Monday about TCP/IP. And even though we didn't talk about the TCP part, we did talk about the IP part, Internet Protocol. And that generally related to this fact that every computer on the internet has an IP address, a unique address that identifies it so that packets, data, can get to it from routers across the internet. Now, the TCP we didn't tease apart, but it does a bunch of things, one of which is that this is a protocol that guarantees delivery. For instance, if with IP, just because or in the real world, just because I extend my hand out like this doesn't mean that the other person is necessarily going to acknowledge my hand being extended, and they're not necessarily going to shake it. TCP, metaphorically, will just keep re-extending my hand until the other end, the server, actually replies. So TCP guarantees delivery. And the other thing that it does is it allows you to do multiple things on one server at a time. So a server these days can be a web server, but it also can be a mail server or an instant messaging server. But if data is just arriving at an IP address, it's not going to be obvious, perhaps, whether this is an email or an instant message or something else. So it turns out that when you address one of these virtual envelopes, thanks to TCP/IP, it's not just the IP address that gets written on the envelope and your IP address and the from address. There's also a unique number that's put on that envelope called a port number. And you might generally have seen that the port number for web services on the internet is the number 80. And the port number for anything secure on the internet with HTTPS is 443. Email is 25. SSH is 22. FTP is 21. And if most of these acronyms are sort of over your head, that's fine. But know that this is the mechanism by which browsers send data to a server and on this envelope say, by the way, this is number 80, port 80, so make sure it goes to the web server and not, say, the mail server or something else. And this feature of port numbers is also such an easy way, frankly, for Harvard to keep you from doing things in your dorm rooms on your computers that they don't want you to do, right? One of the reasons you can't really put your Wii on the network and actually play networked games by default is because Harvard is filtering out some of the traffic. And they're doing this by a couple of mechanisms, but one of which could very well be based on port numbers. If Harvard just wanted to unilaterally say, no more web access for anyone, but you can send email, all they would have to do is configure their routers, or more specifically firewalls, to disallow any packets flowing through harvard.edu that have the number 80 in them. And corporate firewalls do this much more so. And we'll talk later next week likely about this tool that came out last year called Firesheep, which actually allows you to sniff traffic and how that actually works and relates to this, although that tool operates at a higher level. So you're about to see glimpses at routers, at packets, at at switches. A switch is just a device that you can plug multiple computers together in, and then the so-called firewall, which you all have at home or even on your computers and software, which just keeps bad stuff out and good stuff in. So without further ado, I give you how the internet actually, with some simplifications, works.
For the first time in history, people and machinery are working together, realizing a dream. A uniting force that knows no geographical boundaries without regard to race, creed, or color. A new era where communication truly brings people together. This is the dawn of the net. Want to know how it works? Click here to begin your journey into the net. Now, exactly what happened when you clicked on that link? You started a flow of information. This information travels down into your own personal mailroom, where Mr. IP packages it, labels it, and sends it on its way. Each packet is limited in its size. The mailroom must decide how to divide the information and how to package it. Now, the package needs a label containing important information, such as sender's address, receiver's address, and the type of packet it is. Because this particular packet is going out onto the internet, it also gets an address for the proxy server, which has a special function, as we'll see later. The packet is now launched onto your local area network, or LAN. This network is used to connect all the local computers, routers, printers, etc. for information exchange within the physical walls of the building. The LAN is a pretty uncontrolled place, and unfortunately, accidents can happen. The highway of the LAN is packed with all types of information. These are IP packets, Novell packets, Apple Talk packets. They're going against traffic, as usual. The local router reads the address and, if necessary, lifts the packet onto another network. The router, a symbol of control in a seemingly disorganized world.
Oops, sorry about that. Oh, let's put this one here, this one here. Oh, this one's here, this one goes here. I don't like this one. Let's go this one, let's go here. A little left, let's put this one here. Another channel here. Let's put that one here. Let's put that one here.
There he is, systematic, uncaring, methodical, conservative, and sometimes not quite up to speed. But at least he is exact, for the most part. As the packets leave the router, they make their way into the corporate intranet and head for the router switch. A bit more efficient than the router switch plays fast and loose with IP packets, deftly routing them along their way. A digital pinball wizard, if you will.
Here we go. Here comes another one. minutes an hour. Watch this, Mom. Here goes. Whoop, we're on the dice. Hey, in there, in there, in there. Over to the left, over to the right, over to the left, over to the right. You got it. Here it comes. Right on. He shoots. He scores. It's going. Hey, wait. Here, watch out. Here comes another one. Oh, here we go. And it's gone.
As packets arrive at their destination, they're picked up by the network interface, ready to be sent to the next level. In this case, the proxy. The proxy is used by many companies as sort of a middleman in order to lessen the load on their internet connection, and for security reasons as well. As you can see, the packets are all of various sizes, depending upon their content. The proxy opens the packet and looks for the web address, or URL. Depending upon whether the address is acceptable, the packet is sent on to the internet. There are, however, some addresses which do not meet with the approval of the proxy, that is to say, corporate or management guidelines. These are summarily dealt with. We'll have none of that. For those who make it, it's on the road again. Next up, the firewall. The corporate firewall serves two purposes. It prevents some rather nasty things from the internet from coming into the intranet, and it can also prevent sensitive corporate information from being sent out onto the internet. Once through the firewall, a router picks up the packet and places it onto a much narrower road, or bandwidth, as we say. Obviously, the road is not broad enough to take them all. Now you might wonder what happens to all those packets which don't make it along the way. Well, when Mr. IP doesn't receive an acknowledgement that a packet has been received in due time, he simply sends a replacement packet. We are now ready to enter the world of the Internet. A spider web of interconnected networks which span our entire globe. Here, routers and switches establish links between networks. Now, the net is an entirely different environment than you'll find within the protected walls of your LAN. Out here, it's the Wild West. Plenty of space, plenty of opportunities, plenty of things to explore and places to go. Thanks to very little control and regulation, new ideas find fertile soil to push the envelope of their possibilities. But because of this freedom, certain dangers also lurk. You'll never know when you'll meet the dreaded ping of death. A special version of a normal request ping which some idiot thought up to mess up unsuspecting hosts. The paths our packets take may be via satellite, telephone lines, wireless, or even transoceanic cable. They don't always take the fastest or shortest routes possible, but they will get there. Eventually. Maybe that's why it's sometimes called the worldwide wait. But when everything is working smoothly, you can circumvent the globe 5 times over at the drop of a hat. Literally. And all for the cost of a local call or less. Near the end of our destination, we'll find another firewall. Depending upon your perspective as a data packet, the firewall could be a bastion of security or a dreaded adversary. It all depends on which side you're on and what your intentions are. The firewall is designed to let in only those packets that meet its criteria. This firewall is operating on ports 80 and 25. All attempts to enter through other ports are closed for business. Port 25 is used for mail packets, while port 80 is the entrance for packets from the internet to the web server. Inside the firewall, packets are screened more thoroughly. Some packets make it easily through customs, while others look just a bit dubious. Now, the firewall officer is not easily fooled, such as when this ping of death packet tries to disguise itself as a normal ping packet.
It's okay, go on. It's okay. No problem. Have a nice day. We are here. Bye.
For those packets lucky enough to make it this far, the journey is almost over. It's just a line up on the interface to be taken up into the web server. Nowadays, a web server can run on many things, from a mainframe to a webcam to the computer on your desk. Why not your refrigerator? With a proper setup, you can find out if you have the makings for chicken cacciatore or if you have to go shopping. Remember, this is the dawn of the net. Almost anything's possible. One by one, the packets are received, opened, and unpacked. The information they contain, that is, your request for information, is sent on to the web server application. The packet itself is recycled, ready to be used again, and filled with your requested information. Addressed and sent out on its way back to you. Back past the firewall, routers, and on through to the internet. Back through your corporate firewall. And onto your interface. Ready to supply your web browser with the information you requested. That is, this film. Pleased with their efforts and trusting in a better world, our trusty data packets ride off blissfully into the sunset of another day, knowing fully they have served their masters well. Now, isn't that a happy ending?
So it does take some liberties. However, hopefully, even though we've been talking about packets and data and IP in fairly abstract terms, at least now you do have some visuals to latch onto as it relates to data actually getting from point A to point B. Are there any questions about the internet or that film? Yes? When it says packets are what? Recycle, that's one of these liberties. That doesn't really happen. You don't really reuse bits. You just recreate them. So I think someone, too, with a lot of that film was having a little too much fun with making their graphics, because kind of it's like, all right, we're done painting the packet. Move on. All right. So, yeah. So a ping of death, actually, so that does relate to something we looked at Monday. When we looked at traceroute, that tool that showed us the path between point A and B, the type of packet we were actually sending is something called a ping packet, or more technically, an ICMP packet. And that is a packet that is sometimes blocked. That's why we saw the stars instead of actual IP addresses. And a ping of death is essentially a ping that's bigger than it's supposed to be, according to the specification. And years ago, in particular, computers were just not designed, some computers were not designed with sufficient error checking, so simply sending a packet, too many bits, over the internet to a server could just cause it to crash because it essentially overflows a buffer. So they've rather fallen out of vogue since. All right, so we looked at HTML. And this is itself just a markup language, not a programming language, but it allows us to start constructing web pages, but only static web pages. Everything we did on Monday, I had to manually type into my text editor, gedit. I then saved it, and then I pulled it up in a web browser. And recall that even though it was inside of my appliance, the appliance is configured just like one of these web servers. So its address locally is localhost, but if we were to give it a public IP address, as you'll be able to do for your final project, then anyone on the internet could actually visit that thing. So recall that we did some fairly simple, if ugly, designs. If I go into the appliance and I go into my jharvard directory, recall that we created this thing called public_HTML. It's a little oddly named, but that's sort of the global standard. Different web servers can call it different things, but most servers do call it public HTML. And then inside of here, we left off with eyes.png, which is a graphics file, and index.html. And the latter is the thing that we actually wrote. And the structure of this, recall, was as follows. At the very top of this file, we had an HTML doc type declaration. So even though it has the open brackets, it's not technically a tag, but that's sort of an uninteresting detail. But all of these other things are, in fact, tags. And the pattern was open bracket, something, close bracket, unless a tag's behavior was to be modified by something called an attribute. And attributes have values. So the general syntax for that was to say open bracket, name of the tag, space, name of the attribute equals, quote unquote, and then the value of the attribute. And you could have more attributes if HTML allows you. You could have foo equals bar and x equals y. You simply separate them in this manner by spaces. But you would look to some documentation or online reference to see what are the legitimate attributes for that particular tag. And then we introduced one other thing that syntactically was a little different. And that's because this is a slightly more modern feature of the web. So we introduced a div tag, which is just an invisible division, a rectangle. And these just typically help with layout of a page, even though functionally they're not doing a huge amount here. But if I wanted to make everything inside of this div tag a certain stylization, like make everything red text, well, I can use something called CSS, cascading style sheets. And this is just a slightly more modern language, still a markup of sorts, not a programming language, that allows you to sort of fine-tune the aesthetics of your web page. Back in the day, and frankly, when that movie was made, the only way you could really stylize your page is by saying font size equals, quote unquote, 1. Font size equals 2. Font size equals 6, and I think 7 was the maximum size. But these were all relative. And folks like Netscape and Internet Explorer and other browsers just kind of arbitrarily decided that font size 6 will be, oh, I don't know, 48 point. And font size 2 will be 10 point. But it was completely arbitrary. And so if you pulled up a web browser to visit some web page and then looked at that same page in a different browser, it might look very, very different. So CSS was introduced for, among other reasons, to try to standardize the aesthetics of web pages and make it a little easier to structure them. So the pattern that is followed for these things called CSS properties is that they generally go in between quotes as values of the style attribute. So the style attribute's a little special in that you can put almost anything you want in these quotes from CSS. And CSS says find the name of the property, colon, and then the value of the property. So syntactically, this is like mixing one language inside of another. So it's a little odd at first, but we're about to introduce a third language today. So realize that what might still look like Greek actually just gets a little more familiar over time. And in fact, anytime you want to pick up some more tags, it really will be as simple as Googling, looking up one of the recommended resources on the course's website. We're not going to introduce you to all of the possible HTML tags because it's just not all that interesting. In fact, all what we have here is pretty much representatives of all of the HTML tags because we have the nesting idea where this is the unordered list with a list item. We have a tag within a tag here with this anchor tag. We have hyperreferences for links. We have images. So we have at least some of those most popular features of the web. And even some of these do have attributes. And then the anomaly, recall, was this guy, the BR for line break tag. And he was anomalous because he didn't have what? He didn't have a close tag. And you could put it there. That would be OK. It just looks or feels a little silly. You might see this. But again, this is sort of conceptually silly because it's a line break. It's either there or not. It's some atomic concept. It doesn't start and then end. So you don't really need this. But realize you might also see it written as this. which is also OK. You might see this slash at the end of the tag, but inside of it. And this, too, would be called an empty tag. But for HTML5, the latest version of HTML, folks decided that some of these conventions were just unnecessary typing. So let's just say open bracket BR, close bracket. And how do you know this? Honestly, you consult the manual. You consult some resource. And in problem set 7, we'll point you at some specific ones. And the resources page already has a few of those. So this, then, is sort of a canonical web page. It is valid in that it's all correct. It's indented, which means it's nicely readable. And know that we could do this. If we wanted to check our web page, I'm going to go ahead and copy this HTML. I'm going to go to validator.w3.org, which is the website of the standards organization, a bunch of volunteers who essentially try to standardize the web in various languages. And you can see that you can validate by something called a URI, which is just sort of a more general URL. It's essentially synonymous for our purposes. You can validate a file by uploading an HTML file, or you can validate your HTML by directly inputting it. So I'm going to go ahead and just paste this in here. So notice I've just pasted in the contents of a web page. I'm going to go ahead and click check. And what's nice about this tool, and what will be very handy for problem set 7 and 8 in the final project, is it's a nice little sanity check. It will literally check your code and say, yes, this is good in green, or you have some issues. And if you have some issues, you can scroll down and actually read what those issues are. But realize that you're not going to be able to use the validator and tell it that the URL of your page is http://localhost/j_harvard, because again, localhost is on your own machine. It's not on the internet, which means some website like that can't access it. So realize that dichotomy there. All right, so let's make a slightly fancier web page. And notice that what I've introduced here is just a couple of more tags. I've got my body tag, but inside of it now, I've got some anchor tag and some h1 tag. So the anchor tag, just for demonstration purposes, just has an empty href. I don't really care what the URL is, so I omitted it. H1 stands for heading 1. And historically, heading 1 made text on a page big and bold. What big means was not well defined. It might have been 48 point. It might have been smaller, might have been bigger. So here, too, is why CSS was invented. So we have two tags, though, inside of the body. And the point of this little snippet is to say that you can maybe kind of start to think of this now as a tree, a data structure. The indentation is for aesthetic purposes and readability. But if you think about it, ignore the doc type at the very top and focus only on the HTML element. HTML says there can only be one root element, so to speak. And that element must be called HTML in all lowercase. Open bracket, HTML, close bracket. And now if you look to the right and below it, everything is indented. But this indentation kind of suggests a hierarchy. Right? The children of HTML, if we infer from the indentation, seem to be tags called head and another tag called body. And so we can actually think of the HTML tag, or let's call it an element now to make it more like a data structure. The HTML element has two children, head and body. Body, in turn, has two children, the A element and the H1 element. And if we really want to get technical, even the h1 element has a child. But it's just a textual child. It's literally the string my space header. But we can think of that now as a tree. So even though we've kind of written this top to bottom, left to right, we could redraw it either on paper or in memory as a more familiar tree structure. So not a binary tree. It's just a coincidence that some of these things have two children. Certainly a web page can have any number of children. But if we kind of sketch this out as a tree, first, I just need some special note at the very top for reasons we won't get into now. But the one that's important is this so-called root element called HTML. It has two children, so I drew two lines from over to the left to the right. One is for head, one is for body. If we then look at head, the head element has one child called title, and the title element has one child, a textual one, whose value is just, quote unquote, my title. And over here, body is the same kind of story. Has two children, A and H1. Each of them has one child. But notice this href. Why, even though this is an arbitrary picture, this isn't any kind of standard way to draw something, why, though, did I draw probably this attribute called href off to the left and not below the anchor tag? I feel like there's some murmuring here. So just, yeah. Yeah, because it's like kind of part of the A tag, and it's definitely not a child, right? It's not a tag unto itself. It's not below it and indented. So we at least need to draw it in some other way. And this is important only insofar as you think about how to implement this in a programming language. If we are actually going to implement, God forbid in C, a web page like this, we could actually create something called a node, using a typedef and a struct. And inside of that typedef struct would have to be maybe the name of the element and maybe one or more pointers to its children, but then also the notion of one or more attributes as well. So this picture should conjure up at least potential design opportunities here, even though in practice we're not going to use C with regard to the web. Rather, we're going to use a language called PHP. But when we get to JavaScript in a week or so, this picture will actually become quite compelling, because JavaScript itself is a programming language that's going to run inside of a browser that will write this code, and it's going to manipulate the so-called DOM, Document Object Model. So this tree that's depicted here, henceforth we'll refer to as a DOM. And what's nice about JavaScript and what makes today's websites so sexy compared to what they were 5 and 10 years ago is because using this programming language called JavaScript, you can take a tree like this and insert new nodes and remove nodes and move things around and make the website much, much, much more dynamic, right? Case in point, we've all kind of gotten fairly used to something like Google Maps. And if we search for 33 Oxford Street, Cambridge, Mass, and hit enter, a few interesting, but things just happen that we now take for granted. One, there's clearly some autocomplete going on. And my own computer definitely doesn't know about all possible 33 Oxford Streets in the world. So there's definitely some client-server interaction going on there. What does that mean? There's a bunch of HTTP requests that just went from my browser to Google and back, and they were giving me these little hints. But what's compelling about this interface, recall, is that it's not reloading. Right? There's still a lot of websites out there where if you want to see more content or look something up, you click like a submit button or you click a link, the whole page goes white for a moment, and then something starts spinning in your toolbar, and then bam, you see the results. And then you hit the back button or click another link. Right? These websites are becoming increasingly user unfriendly because the bar has been raised by sites like Google, because Google's using a technology called AJAX, which is the use of JavaScript among other things. And even this, right? You might not recall using something like MapQuest, which was one of the first map tools out there, or even Yahoo Maps, where if you wanted to go up or down or left or right, you click a stupid arrow, and then that part of the map reloads, and then you click it again and click it again. And just a few years ago, it was a really powerful thing when Google started actually letting you click and drag so that the whole website is not reloading, just the contents of this frame. And now there's even Google Earth, which makes things even more fancy and more 3D and interactive. So the web is really getting much, much more interesting. So over the next couple of weeks, we're going to learn how these things work and how you can make them do your own bidding. So without further ado, let's introduce just a couple more sort of mental things with which to proceed, and then dive into this programming language, PHP. So this is just a slightly more complex example of HTML that allows you to include other files in your web page. So recall sharp include from C, which allows you to include a header file inside of your own C file. Well, HTML has a similar mechanism whereby if you want to put all of your cascading style sheet information, font color red, font size 24 point, and so forth, if you want to actually put it for design reasons in a separate file, you can do that in a file called, say, styles.css, which is also going to be in your public HTML directory. And if you want to tell a browser that, hey, by the way, you have to go and load another file before showing the user this web page, you can use the link tag here. Link and then rel for relation equals style sheet. And then href here is not a link. It's saying, go grab this other file called styles.css from the server and then use it to display this web page. And we'll see in a moment what something like this might look like. Below that, you see a script tag. And you might be able to infer from this that this relates to this language called JavaScript. So in a week or two, when we're writing JavaScript code, if we want to integrate it into our web page, but not just copy and paste it into the actual HTML file, but keep it separate for good design purposes and readability, similarly, can we include a file like this? Now, just to give an example of how this works, if we go to, say, even CS50.net, and I just happen to know from the source code that if I go into, let's see, styles.css, that's not it. I don't seem to know. Let's do this. I don't remember where we put it. So I'm going to go ahead and right-click or control-click, view page source, and you'll see that there's a whole bunch of stuff going on here. And the formatting is actually pretty messy because a lot of the CS50 website is generated by a computer, by programs written in PHP, so we don't ever really manually type this out. So if I kind of scroll through this, and it's actually a little messy here, that's what I was looking for. I wanted this link tag, which says the stylization for CS50's website is apparently in a folder called CSS, not styles. That's what I got wrong. And in a file called styles.css. So let's go there. So let me update the URL to be that and hit enter. And what we'll see in here is more complexity than we'll dive into for now. But you see a whole bunch of things. Let's find a simple one like this. So you might recall that atop the course's website are often these things called announcements at the very top of the page. And right here, we have a mention of problem set 5, problem set 6, and so forth. And this box always has a little FYI logo up there. It's kind of gray background and blue links. Well, the means by which we did this was in here. Long story short, we have a div somewhere in the page for this rectangular set of announcements. We gave it what's called an ID, which is just a unique identifier, so that we could say there might be a dozen divs on the page. This is the one we want to stylize. So div sharp sign FYI, and then the open curly brace, close curly brace. And inside of that is, again, this thing called a CSS property. The font size of those announcements we decided should be 77%. Now, what does that mean? Well, we gave some thought to what the default font size should be on the website and decided the announcements should be 77% the size of the default size. And then how about this? Div sharp sign FYI A. Well, A is the anchor tag. This just refers to the very specific div in the web page where the announcements go. Well, this is what gives the announcements their color, the specific color we're using, which is a light blue. And text decoration none. You might recall that on the web, by default, most links are underlined just to draw attention to them. But this is falling out of vogue. So the means by which you disable underlining is a CSS property called text decoration : none. Do not decorate the links. And so this is, again, just a teaser of the sorts of things you can see, and just realize that the CS50 site is more complex than a typical one. And frankly, if we go to something like Facebook, let me go ahead and pull up view page source. I mean, you'll see a whole bunch of HTML here, also machine generated, so it's a bit messy to read. But if we scroll to the very top, there's the doc type. So that part of our story is true thus far, that's part of the web. HTML is there. There's some other attributes that we haven't used, but those don't really change the story. There it is. Title, welcome to Facebook, log in, sign up, or learn. And here is some CSS. So let's see what Mark and company have been writing in the way of CSS. If we go, let's choose this. I have no idea what this file name means, but I'm going to copy the URL, paste it, and it looks like someone at Facebook wrote all of this CSS. If I take this one here, someone at Facebook wrote all of this CSS. And again, not interesting to glance at, except there are some sort of self-explanatory things about background images. So that's how they have some image on the screen. Things about width and so forth. And then if we go to JavaScript, just as a teaser for next week, let's go into this cryptically named URL. Here is a whole bunch of JavaScript code that someone wrote, lest you completely freak out as to what's on the horizon. They wrote this JavaScript and then did what's called obfuscating it or minifying it for reasons of bandwidth and cost, and also sometimes intellectual property. You might write JavaScript code in a very readable way. This is not what we're going to write. You use nice indentation, nice variable names, nice function names, and the like. But when it comes time to post that code on the internet, clearly any random guy with a browser can look at it. And also, white space is useless for a computer. It's only really useful for a human. So to save money, because transferring data, certainly on Facebook scale, costs money over time, because they have to pay someone to transfer data, and because they don't necessarily want MySpace or someone else copying all of their fancy features outright, you can minify it, which does not make it impossible for smart people to figure out how your code works, but it raises the bar. And this, too, is a theme in security and intellectual property in general. You really can't keep someone from figuring out or understanding or even duplicating your handiwork, but you can at least raise the bar so that it's more time-consuming or more expensive them to figure it out than it would be if they just started from scratch and wrote it themselves. But the exception there relates to anything server-side. So HTML, CSS, and as we'll see, JavaScript is all client-side, so to speak. It's in the browser. All the PHP we write, all of the database stuff we do, is going to be server side. And that's where really the intellectual property is. And frankly, Facebook's value is in its data and it's in its users, not in some random JavaScript code that they've been writing, as much as that might please users. So let's take a look now at a familiar website and see if we can't implement a little something like it ourselves. So here is google.com. I'm going to go ahead and do one thing first, because Google's getting a little too fancy for its own good. I'm going to go to Search Settings. And I'm going to turn off Google Instant. Google Instant, as you may know, is a feature introduced a few months ago. And it all of a sudden like shows you your search results before you hit Enter. I want to kind of do it old school style so we don't get ahead of ourselves, because I want to actually have to click a Submit button before we actually search for something. So here we have now the Google homepage. And I'm going to go ahead and search for something like Harvard. Enter. And voila. Once I hit Enter, Harvard, thankfully, is the top hit here. So now we actually see the page of search results. But how did this happen? Well, let's look a little closer. Here's before, obviously the default homepage. And here's the URL. Notice that Chrome is being a little excessively user-friendly. What's really there is this. But for reasons of aesthetics and simplicity, a lot of browsers are just hiding this. But http:// is implicitly there. And now notice when I actually click Submit after searching for Harvard, Enter, notice that the URL changes to something much, much more complex. But it's all related to what I just did. Let me go ahead and copy this. Let me go ahead and open just a temporary text file and paste this in just so we can see it a little more clearly. And it's definitely an ugly URL. But let's just throw away anything that confuses us. So I have no idea what this is. But it seems like it relates to English. EN is generally the shorthand notation for English. Source, I don't really know what HP is, so I'm going to delete that. BIW, don't know what that is. BIH, maybe heights. Maybe there's a with thing going on here. OK, Q equals Harvard. Sounds familiar. So Q, query, probably. So let's leave that. OQ, I didn't type OQ, so let's get rid of that. No idea what this is. Definitely have no idea what this number is. So Google's doing a lot of stuff, right? They do advertising. That's the technical explanation. So this was like version 1. When Larry and Sergey first made Google, it really did work as simply as this, with one input coming from the user before all this era of advertising and the like, and user tracking. So let's see what happens if I just take this URL, go back to a browser, click Enter. So it actually still works. So even sort of old school style, this URL works. And this is nice, because I can kind of wrap my mind around this URL. The other one's a little overwhelming. So notice that by default, the text field is being filled in with the word Harvard. At the top, I have google.com/search Q equals Harvard. So let's tease these things apart. So the domain name here is www.google.com. Slash denotes the root of the hard drive, the server that Google's using. Now, in reality, they have thousands of servers. But let's simplify. One server. And so in that server's hard drive is apparently a file called search. And that file is a program. Maybe it's written in PHP, Python, C, C++. Who knows right now? Though generally, Google does a lot of stuff in Python and other languages. So /search is the program. And it turns out that the convention on the web is anytime you have a question mark, after that question mark are the inputs to the server. So just as in C, you can provide inputs via the command line or by using getString or similar and waiting at a prompt and typing Enter. The web works in such a way that servers take input by way of URLs with question marks and then key value pairs after them. So Q is the key. Equal sign separates it from its value, which in this case is Harvard. And if you have multiple ones, they're separated by ampersand. So if I had x equals y and w equals z, we would just separate them by ampersands. And that was, I deleted, recall, a whole bunch of ampersands. So that's how Google's apparently working. But how did the web page lead me to that URL? I didn't click a link. I typed in the word Harvard, hit Enter, and then magically this URL changed. So let's go back to Google's homepage and see if we can't make a little bit of sense of it. So I'm going to view page source. And oh my god, this is going to be a lot of stuff to delete, right? So as an aside, especially someone like Google, there's fascinating scalability effects here. If someone at Google so much as hits the space bar once, which creates a single byte of white space, and then everyone in the world proceeds to download that home page in a day, suppose Google gets 1 billion hits. The mere fact that some programmer hit the space bar means 1 billion extra bytes were sent from Google throughout the whole world. That's a gigabyte just because someone hit the space bar. So one of the things Facebook and Google and all of these big sites do is, again, they minify their code. They throw away white space. They automatically shrink variable names so that it's not readable both for obscurity purposes but also for financial purposes. So let's scroll down. Oh, my God, a lot of HTML here. But that's OK. Let me actually go inside of the appliance and use a different browser. Because by default, Firefox, recall, comes with some tools pre-installed. We used one on Monday called Live HTTP Headers, which just let us sniff the traffic going from browser to server and back. But today, I want to use an even more popular tool called Firebug. So Firebug is a free plugin for Firefox. Comes in the appliance, but you can download it for your Mac or PC. And what it allows you to do is actually look inside of web pages a little more neatly. So I'm going to go ahead and again disable instant search because I want the old school behavior. Save preferences. And now I'm inside of the appliance. I'm at google.com. I'm going to right click or control click. And notice once you install Firebug, you have a special menu here that shows up called Inspect Element. I'm going to click this. And what this does is it opens a little window at the bottom of the browser that does a bunch of things. But the most useful is it just cleans everything up. It adds white space. It adds indentation. So as you're trying to learn how websites work, or if you're trying to borrow someone else's design, you can actually see much more neatly in this way. So here we have the doc type declaration. Here's the HTML tag. Here's the head tag. And notice I can even collapse these things just to help stay sane as I'm exploring this. So let's go into the body here. It looks like there is a div tag, an iframe tag, a center tag. You know, I don't know what most of these are yet, but center probably means make this centered. So we keep going, and here's the interesting one today. So websites become dynamic when they actually take user inputs. They have text fields or drop-down menus or checkboxes, all of these very familiar, mundane things. But this is what now makes the web interesting, because the page can change every time I visit it if it has something called a form. So if I scroll down here, apparently there's a tag in HTML called form. It can take a bunch of attributes, one of which is name, one of which is action. Well, action has a value, and the action attribute is defined in HTML documentation as being the URL to which you will be sent upon submitting a form. So skim the manual, that's what it says. So this is sort of a shorthand URL. Because there's no HTTP : / the browser is going to assume that /search refers to whatever server got me to this point. It's going to assume the default of google.com. Now there's a bunch of distractions in here, and apparently this is the source of some of those crazy names we saw: input OQ, AQ, AQI, AQL, and so forth. Well, notice that these are all hidden. Firebug is being friendly and trying to gray them out, just to draw my attention to the fact that these are inputs that are there, but Google put them there. They're not things that I can see. But I want to see Q and the form that I'm actually filling out. So it turns out there's a table tag in HTML. There's a table body tag. There's a table row tag. There's a table data tag. And if I keep going in here, notice that, OK, finally something a little more familiar. There's more divs. There's a BR input. But this is interesting. There's an input tag. An input tag that takes a bunch of attributes, one of which is type equals submit. This is what makes it a button that's clickable. Another of which is value. So if you've ever wondered where the label from a button comes from, actually, no one's probably ever wondered that. But now if you want to know, the label on these clickable buttons is coming precisely from this HTML. And that I'm feeling lucky button that's been part of Google's history is right here as well. Now, as an aside, the nice thing about Firebug 2 is that you can actually tinker with a website. I can even say, I can go into the HTML here, and I can say I'm feeling, say, unlucky, enter, and voila, I've changed google.com. But obviously not. I've just changed it locally. But the value here is that I can actually tinker with my websites, with others, just to understand how they work. If you pull up google.com now, it will still say, I'm feeling lucky. So what's the takeaway here? It seems that this is the beginning of a dynamic website that is really a program. It's a form. This is the means by which we're getting input. And now Google's providing the back-end intelligence for searching. So let's see if I can't now leverage this same idea and reinvent this wheel and customize it for my own website. Let me go into gedit here. Let me go ahead and create a new file. I'm going to save this as google.html, enter. I'm going to go ahead and then do a bunch of familiar, actually, I'm going to go ahead and copy paste and then change some things. So I'm going to call this CS50 search. We're going to ditch yesterday's pink background. We're going to get rid of all of this, in fact. So let's just get to the bare bones of a website here. So now we have something pretty minimal. And now I'm going to borrow this new trick. I'm going to say, I like that center tag. That's kind of friendly, so let's do that. And now I'm going to do a form tag. A form needs a name. It actually doesn't need a name, so I'm going to skip that one. But it needs an action. /search. Let me close this tag, form. And then this form has to have a few things. And we didn't look at this one explicitly, but there was another. Input type equals text. And what was its thing? Let's take a look. Back at the HTML, let's do a quick control click or right click. And actually, if you click on specific things, if you right click on the form field and click inspect element, it will jump right to it. So you don't have to futz around trying to find it. So notice this is a pretty big input tag with a lot of attributes apparently. But the only one I care about is here. At the very bottom, one of the attributes is name equals quote unquote Q. So I'm going to steal that same HTML and re-implement it myself. So here we go. Input type equals text. Name equals Q. And I'm not going to give it a value, but I am going to have a button. Input type equals submit. Value equals CS50 search. And let's see where this gets us. I'm going to save it with this pretty minimalist design. I'm going to go, let's see, I want to open this in a browser. So I'm going to go back to the appliances desktop. I'm going to go into my home directory. Actually, no, let's do it via the web browser. So localhost /tilde-j-harvard, google.html. OK. Not quite Google, but I'm on my way, right? So I have a form here with a text box. I have a button, CS50 search, but it's not quite Google yet, because the button I really wanted on the next line. So what was the trick for fixing this issue yesterday, Monday? So we can do like a BR tag. Let's see. Let's save and reload. OK, so it's not quite as pretty as Google, but let's even add their I'm feeling lucky button. So input type equals, let's say, submit. Value equals I'm feeling lucky. And close quote. Let me reload my browser. OK, it's starting to look like Google. And in fact, if we really want to be ridiculous, if we go to a particular URL here, let me steal from our demos today. CS50 search. Nice. All right, so now I have my own logo. Save image. I'm going to save it as search.gif. I'm going to put it into where? John Harvard's public HTML directory. I'm going to click Save. OK, I'm going to go back to my HTML. I need that image tag. So let me go up here and do img src equals search.gif. I need a line break. So now let's reload my browser. Reload. Not appearing. Why? Yeah, so it might be a permissions issue. So let's check. Let me open a terminal window. And let me go into my public HTML directory. Let me do an ls. Oh, but wait, ls isn't good enough. ls-l for the long listing. And sure enough, there's search.gif. But it means only I have read and write permissions. So the fix for this, recall, was chmod all a plus r, all plus read, search.gif. Enter. Let's go back to the browser. Sometimes you'd see like a broken icon or something like that. But Firefox in Linux apparently just shows it as white. Very nice. So now we're on our way here. So now let me go ahead and search for Harvard and see if I'm done implementing Google. OK. So not found. So obviously, I'm cutting some corners, among which is I didn't implement search, right? I didn't implement a program in PHP or any language called search. OK, that's fine. I'm pushing up against the deadline here. psets due, http www.google.com/search. So let's go back here. Reload. You got to reload your HTML, otherwise the change won't take effect. Now I got Harvard, CS50 search. Nice. I have re-implemented Google. All right. So clearly we've cut some corners. So now let's see how we could start implementing things underneath the hood there. Let me go over to gedit here. This is all HTML. Feels like it's going to be time to introduce a bit of PHP. So PHP is now an actual programming language. It's a language that's going to be executed server-side, not inside the browser. So anything we do with PHP is never going to be seen by the user. But using the equivalent of printf, we can write PHP code that spits out HTML, that spits out CSS, and we can dynamically create our web pages. So let me actually go ahead and download some of today's code. Let me go back to lectures. Let me scroll down here, source code, and let me download. Actually, let's do this. I feel like people are getting antsy. Let's take a 2-minute break. I'm going to go ahead and download some code, and then we'll come back and start writing this backend ourselves. All right, so we are back. So it turns out one of my primary extracurriculars in college was actually running with one of my roommates the freshman intramural sports program. And so this was back in the day, almost before the web, whereby if you wanted to register for soccer or frisbee or whatever, you would actually fill out a piece of paper. You would then walk across Harvard Yard, swipe into Wigglesworth, walk to the door of the proctor, who was really in charge of Frosh IMs, and then drop into their mailbox, their door drop, your registration form. And thus was freshman intramural sports. So there were like web servers and web browsers in 1996. And so this was just a kind of a campus problem waiting to be solved. We can do better than trekking across campus to Wigglesworth to register. So having taken at that time CS50 and 51 toward the end of that year, I decided to learn a language on my own called Perl. Perl is still very much in use, but it's been supplanted by even more modern languages like PHP, Python, and Ruby. But it was with this language that I implemented the first sort of online registration system for Frosh IMs. And it was really simple. All we wanted to do was allow people to go to a web page, fill out a form like this, click submit, and then that proctor could download the equivalent of an Excel file. Or we could even email people to confirm that they had, in fact, been registered. So I tell this particular story, even though it's a different language, in that really, after CS50 and maybe even just one other class, it really is possible to bootstrap yourself and learn most any language that's similar syntactically to C and, as we'll see, PHP. It's very deliberate that we'll spend very little time on JavaScript and PHP relative to C, because you'll see syntactically they're quite similar, and also conceptually they are similar as well. They simply solve different problems more easily. So with that said, here's a web page. Let's actually look at its source code. If I view page source, I'm going to see a bunch of HTML, and there's definitely some new features here. So what's here? I have my doc type, HTML, head, title, a div, text align, center. So this is actually the more proper way to center something in a web page these days. There's an H1 tag, which again means big and bold. Here's a couple of line breaks. Here's a form field. And here's something interesting. Now the action value is actually to a .php file. PHP is, again, a programming language. And because there's no HTTP, it must be that register1.php lives in the appliance, or really in the same web server as whatever file I'm currently viewing. So method equals post. It turns out that not all of the data you send in a URL needs to be transmitted in the clear. In fact, it'd be a very bad thing if your password and credit card number and anything private was just sent to a server via the URL, because one, you can see it. That's not so worrisome. But your roommate can see it if he or she goes poking around your browser history. So thankfully, there's another way to send information from browser to server. And that's not using HTTP GET, but rather it's using something called HTTP POST. And to induce a post, you simply say method equals quote unquote post. So post is going to keep the information out of the URL, but it's still going to send it. All right, so what comes next? There's apparently a table tag here, table row, table data, and this just creates some kind of tabular structure. What tabular structure? Well, behind the scenes here, there's an invisible table. The name, captain, gender, and dorm words are in the left column, and all of the form fields are in the right column there. So that's what's going on there invisibly. And if I go back to the source here, notice some familiar things now. So I see mention of like dorm and gender in captain, applicort, candidate, grays, greeno. So let's see how these are here, how these are inputted. So name, colon. So this TD tag, table data, this means left column. This next one means right column. And I'm using an input tag that has a name of name, but this means person's name, freshman's name, and then type equals text. I have a text box here. So there's also type equals check box to say yes or no, you want to be a captain for the team. Gender is a radio button. So this is one of these mutually exclusive ones where you can either click this button or this one, and clicking one unchecks the other. And then dorm is a drop-down menu, otherwise known as a select menu in HTML, whereby the name of this HTTP value is going to be dorm, and it comes with a whole bunch of options. So I just typed out option value equals quote unquote for nothing, so it defaults to nothing. Then applicort, candidate, grays, greeno, and so forth. And notice the dichotomy here. Just like with anchor tags, where you can have a URL that's clickable, but the word you're clicking is different from what the user actually ends up at. Same here with select menus, with drop-down menus. The option value, quote unquote, this is what's going to get sent to the server. This is what the user is going to see. In this case, for simplicity, they're the same. But if you wanted to have a more user-friendly description, maybe more words than just 2, but still just send something succinct to the server, you can do that, hence this dichotomy. And then if I scroll down further, we're almost done with the HTML. Here's my submit button, value equals register, and then the rest of the page gets closed. So let's see what happens when I fill this out. So David, Captain, M, let's say Matthews, register. OK, so I didn't actually implement this side of it either, but I did get redirected to a register1.php file. And it's in this file that we'll see the beginnings of our web programming. So let's go into gedit. Let me go ahead and open up in my frosh.ims directory first frosh.ims1.php. So notice a couple of things. Even though, and let me go back to the browser, we started that at this page here, notice what the URL was. Notice that the URL I started at, even though it's only HTML when I look at it, it actually is a PHP page. So here's the interesting thing about PHP. You can commingle your PHP code, which we'll soon see, and HTML, whereby PHP can generate more HTML. And just to make this more concrete, this is actually kind of an inefficient way of outputting dorms, right? Typing out that list of dorms is actually pretty tedious and boring. And if I have multiple websites that ask students where they live, I'm every time copying and pasting or typing out a dozen or so dorms. Well, it would kind of be nice to put that dorm information in a database. Just ask the database, give me all of the dorms, and then have a for loop or a while loop that prints out each of those option HTML tags. And indeed, we can do that. We're not doing it yet, but that's why you might want an actual programming language, so you can ask a database or some other source for information, and then only write like 2 or 3 lines, not a dozen or more. So let's actually look then at frosh.ims1.php. And even though it's called PHP, it's all HTML. So notice that I'm not yet writing any PHP code, but I could be in register1.php. So notice that register1 actually has a bit of code. Let me zoom out so this is all clear. Notice the following features. At the very top of a PHP file, I have open bracket question mark. So this looks kind of like a tag, but the fact that the question mark is right there means this is not HTML. Here comes some PHP. This is necessary because on the server, or in this case the appliance, when the web server notices, this URL ends with .php, that is not a static file. That is not HTML. That is not CSS. That is a program. So the web server is going to notice the .php file name. It is then going to execute this program. It's going to execute the file called register1.php. What does it mean to execute the file? Well, it's going to look anywhere there's an open bracket question mark and then some stuff, followed by a question mark close bracket. The web server is going to execute that PHP code, and whatever that code outputs via printf or similar will be sent to the browser. It doesn't need to output anything, but it can. So let's see what's actually happening here. First of all of this is comments, and for the moment, a big distraction. So I'm just going to delete all of those comments. They're just like C comments, but in this case, we're in the context of PHP. But it looks like, had I actually been a little difficult and not typed in David and Male and Captain and Matthews, I actually would have not submitted this form successfully. So let's actually try that. Let me go back to my browser and not be a cooperative user. I'm going to uncheck that. I'm going to unchoose a dorm. And I'm only going to provide gender and name. And I click register. And now notice it did not submit. All right, maybe it was my mistake. Let me do this again. I'm not going to check. They don't need to know my gender or my dorm. I'm just going to register. Well, apparently they do, because notice I'm going back to frosh.iams1.php. I'm not going to the registration page, it seems. So why is that? In register1.php, there's a very simple branch, a very simple condition. So think back to Scratch, think back to C. The idea is the same, even though the syntax is a little different. Notice what's going to happen here. If empty. So it turns out empty is a function that returns true if the variable you give it is empty. There's nothing there. Otherwise, it returns false. So it turns out this is a variable. So in PHP, what's nice is anytime you submit a form to the server, if you submit using method equals quote unquote post, all of your form inputs are stored in one big variable, and that variable, turns out, is a hash table. Recall that a hash table is a fancy new data structure that you're playing with perhaps for problem set 6, and it allows you to store keys and then values. In the case of problem set 6, if you're using a hash table, the key is the word from the dictionary, and the value is something like yes or no. It's there or it's not there. That's the kind of answer. So in the case of this, the variable here is called $_post. Frankly, it's a stupid name. The fact that there's an underscore is annoying. The fact that it's uppercase, though, at least suggests that it's important. And $_post is a special variable, a hash table, if you will, that you can index into just like an array. So with the fact that I'm saying $_post, open bracket, close bracket, and then in quotes inside of it, name, means go inside of this hash table and give me the value of the parameter called name. If the user typed in David, that's what I'm going to get back. If the user typed in nothing, I'm going to get nothing back. And so this function empty is going to return true, because indeed the form field was empty. The double vertical bars here mean the same thing as in C. Or if the gender field is empty, or if the dorm field is empty, what do I want to do? Well, I want to do what's inside of this if condition. And what's inside of this if condition? A new function, header. Header takes an argument. And what does this suggest? Where have we seen headers before? Well, think back to Monday when we used live HTTP headers and we sniffed our web traffic. And among the headers were things like get/HTTP and host : and then there was some mention of your browser. There was a lot of interesting or juicy data inside of the headers that we humans don't see, but the browser and server are seeing. Well, it turns out another one of them is the so-called location header. If you've ever visited a website and then been magically redirected to some other website nearly instantly, how is that working without human intervention by you? Well, what the server is doing is if you visit google.com and Google decides, we don't want you using google.com. We want you using www.google.com. What Google's server will send is an HTTP header that looks like this, location, : and then the URL they want you to go to. Let's actually try to see this. Let me go back to my browser. I'm going to go ahead and actually clear my history so that we haven't cached any of the previous Google results. And I'm going to go ahead and open up live HTTP headers, just like Monday. And I'm going to visit not www.google.com, but more specifically http://google.com and hit enter. And notice the URL definitely changed. This is not my browser doing this per se. It's the server, because if I scroll up, notice that here's what I asked Google. Give me / on google.com. And you know what Google said secretly to me? We have moved permanently to http://www.google.com. Now, why? Mostly it's for branding purposes, but also sometimes for technical purposes. It is absolutely possible for both something.com or www.something.com to work. But in Google's case, they've decided that they are branding themselves as www.google.com. We do the same with CS50.net. But if you watch the videos, we chose CS50.tv with no www just because it sounded, frankly, better. And you can do that with your web server. So what this question is asking is, if the user didn't give me a name, didn't give me a gender, or didn't give me a dorm, to hell with them. Redirect them back to the very same URL from whence they came, which is this URL here. And that's exactly what someone like Google is doing. They're not using PHP, but they have an if condition somewhere that says, if not www.google.com, go to google.com. And they will force your browser to actually go to that point. Now, just to fast forward to a teaser, I'm going to go ahead and open up, say, register 8, which is going to be version, nope, not register 8. Let's try register 3. So register3.php is going to be, as we'll see, the third version of where we're going with this. And in this line of code, notice I'm reversing the question. If name is not empty, And gender is not empty, thanks to the exclamation point. And dorm is not empty. What you can do in PHP amazingly simply, or relatively simply, is here are 8 or so lines of code that are going to create a variable called to, as an aside, or as you might have inferred, variables in PHP, just because, all start with $signs. There's going to create a variable called subject. It's going to create a variable called body. This dot operator is concatenation, so this is just a stylistic thing. This is all one huge string, and I'm substituting in the user's name, captain, gender, and dorm into this string. Then this is here just for a from address, and then this. If you want, in a language like PHP, to send someone an email from an arbitrary address to an arbitrary address, much like the proctor might have wanted back in the day, to confirm someone's registration, it's one line of code. It's a function called mail, takes a few arguments, the to field, subject field, body, and any additional email headers. And voila, freshman now has received an email confirmation of their registration. And this is what's going to be really exciting about PHP. Even though we've got some new syntax and some new mental constructs here to think about, doing things that are useful and compelling will consistently reduce to very few lines of code. PHP gives us the same features as C ultimately, but much more user-friendly, much easier to write, and much less code to write. And with it, can we build some amazing things come final project. So with that said, we will see you on Monday.